Columns are one of the vertical components of a structure. Other vertical components of a structure, for example in a building, include shear walls and brick walls. The principal task of the column is to transmit external charges applied on the superstructure to the infrastructure through the load transfer mechanism. These charges are introduced into the structure through various means such as gravity, wind, earthquake, and other external forces. It is well known that while in the process of transmitting the charges applied on it, internal forces, which are axial forces, bending moments, and shear forces, develop in the column to generate an equilibrium to the applied external forces. The columns are the most important elements of any structure because in most cases, their failure simply means the failure of the whole structure. Let us now look at the factors to consider while calculating a column. The first one is the material of construction used. Characteristics of materials such as density and Young modulus, which is also known as the modulus of elasticity, differ from one material to another. These characteristics are important in determining the self-weight of materials and also to determine how the material will react under loading. Second one is the geometry of the individual columns. The shape of the cross-section is paramount in this calculation. This is due to the reason that geometrical characteristics of shapes, which are the area, first moment of inertia, second moment of inertia, and radius of gyration, differ from one shape to another. These characteristics are pivotal in determination of the capacity of resistance to loading. It is very important to note that the chosen shape has to meet the architectural aspect additional to the structural performance of the columns. Apart from the shape, the height of the column should also be considered. This is important as it helps determine if the column will buckle or not. An important factor called the slenderness ratio is directly related to the height of the column. This factor indicates the tendency of a column to buckle. The higher the height means a higher value of slenderness ratio, which indicates a higher risk of buckling. Speaking of buckling, it is the sudden change of shape of a structural component subjected to axial compression which leads to the loss of load carrying capacity. Slender components are at a higher risk of buckling. Having considered all those factors, let us now look at the general steps of calculation. In the case of a column supporting a slab, the effective area being supported by the considered column is used to determine the concentrated load acting on the column. Since the evaluation of load is given per unit area for a slab, multiplication of the estimated load of the slab by the effective area results in a concentrated force acting upon a column. Since the yield strength of the material is known, it is easy to determine the minimum area required to support the concentrated force acting on the column. It is important to note that the effects of the horizontal load generated mainly by the wind or earthquake and the second order effect should also be considered before giving out the final cross-sectional area of the column. These are the forces that help to maintain the equilibrium from the external force applied on a structural member. Different methods of determining these forces exist. For simple structures, it is easy to determine these forces mainly using the resistance of material methods. But once the structure becomes more complex, a software may be used to save time used in calculation and also to reduce the margin of errors. After the determination of the internal forces, it is important to verify that the structural elements can sufficiently support the applied forces. Generally, elements with the highest value of the internal forces are considered during the designing process, as these elements are at a higher risk of failing. And values of these elements can be applied to all other elements under the same category. For RCC members, the designing process includes determining adequate reinforcement for areas under tensional stress. While for metallic or wood structures, the process includes also several verifications according to the design code being applied. And that bit brings us to the end of today's video. Thank you for watching and please feel free to use the comment section. Make sure to hit the subscribe button below for more of such content. See you on the next one. Peace.